Thank you, Marie. Hello, everyone. Thanks for joining us today. As Marie said, I'm Tony Gleeson. I'm the CEO of ERA, but more importantly, chair the steering committee for the Innovation Hub. Firstly, I'd like to just acknowledge how we meet and where we meet. And as we go to the next slide, I just want to acknowledge the traditional owners of the country throughout Australia and recognise their continuing connection to the land, water and community. We pay our respects to them, their cultures and to their elders, both past, present and emerging. As we kick this off today, I think it's important to recognise that our funding is coming through a grant that we received through ARENA, the Australians Advancing Renewables Energy Program. And we've been in place for more than 12 months, or just on 12 months, I should say today. The project itself has been moving forward over a number of years. It was driven out of ERA's Prime initiative, and that initiative was really to drive or to help support a low carbon emission future, and more importantly, in this case, to provide affordable heating and cooling through those initiatives. And so we've been very fortunate to be able to work with a lot of very great partners. And today's a good example of a partnership of working together, particularly with CSIRO and Stephen White, who I'll introduce in a moment, leading that way. But I think it's really good to show a number of examples of industry working with research, working with various parts of the community to be able to produce some really unique findings, and more importantly, some unique output is going to be very usable. And today is very much about sharing that knowledge that we have out there. These will be continuing on throughout the length of our program. ERA has funding till the mid-2022. We have 16 current projects in place, and that's growing almost each month, but certainly growing on a continual basis. And that's been critical for our success, to get the various elements of the communities together. So I'd like to now hand over to Stephen White, who will now take us through what the Integrated Design Studio is. And more importantly, before I leave, my bit is that all the information you can find here today from the Innovation Hub on our website. The recordings will be up there. You'll also find a lessons learned report. You'll also find the latest news on various projects. So again, keep up to date on what's happening here through our website, www.ihub.org.au. And that's now all for me. Stephen, over to you.
Thanks. Yeah. So my name's Stephen White. I run the energy efficiency work in CSIRO, and I'm also the operating agent leading the International Energy Agency Annex 81 data-driven smart buildings. Obviously, that's highly relevant to the work we're doing here in the data clearinghouse activity of the iHub. As Tony mentioned, this data clearinghouse is one part of the iHub there, and it was born out of the Prime initiative. And one of the interesting innovation opportunities that came out in all the consultation work that was done was around building control systems, automation, and software services. You know, there was this quote from the report that ERA put out at the Future of HVAC 2016, that building control systems are in the mainframe age of computing, not having advanced to the app age. I thought that was quite a cute comment. And at least those sort of sentiments that came through from over 150 people in consultation there at the Future of HVAC helped to form the need for this particular activity. So it's very much about helping the building automation and HVAC software services industry, really trying to help them achieve scalability, and particularly in the case of the iHub project and with the support of ARENA, it's how can we enable renewable energy there. Enabling renewable energy is about improving the value of renewable energy by avoiding export and by using as much of the solar energy produced on site, but also even at an aggregate level, looking at the extent to which the buildings industry and HVAC in particular can contribute as a flexible load in the NEM. And we do have a presentation on that part of it later on. So really fundamentally, the data clearinghouse is really looking at buildings as a distributed energy resource. That is, as a component of an energy system that can actually change its energy consumption in some form or other. And this diagram here is a bit of an attempt to explain that, where you have the building, and there is load information, on-site photovoltaics, and storage. Storage could be in the form of batteries, but clearly from a thermal perspective, the idea that buildings have a thermal storage component which creates flexibility in the electricity system is important. But we've got all these emerging digital technologies, the Internet of Things with sensors producing data, and we've got vast amounts of data available on the Internet, that's, and particularly useful ones in the context of distributed energy resources, includes weather forecasts and energy market data. So really, can you capture all this disparate data, pull it together in a consolidated fashion in the cloud, and use that to develop knowledge, to enable the management of buildings, and even potentially to take control action in the form of load scheduling? And so the data clearinghouse is really focusing in on that data aggregation component and the use of analytics to drive better decision making and control. So that little cloud bubble there with time series data management and analytics is kind of the focus of this activity. And then how do we use that in terms of driving demonstrations, applications in different building typologies? So today's agenda, I'll give you a little bit more detail on this thing called the data clearinghouse and the philosophical high-level sort of place that we're coming from with that. Subbu Sethuvenkatraman from CSIRO will drill a bit deeper into semantic web technologies and how they would be deployed and how we can use modern IT practices in the industry. We'll break for a little bit of Q&A on those two presentations, chance to raise some questions, and then I've got a couple of sort of forum style approaches with Q&A with Arne Hansen on data sovereignty and Iain Stewart on open innovation. Data sovereignty being sort of one of the potential barriers or one of the things that we need to address, and open innovation being at the core of why ERA would be involved in helping to stimulate innovation in our industry. And then, as I promised, some of the work we've been doing and sort of working out the size of the prize here is a presentation from Mark Goldsworth on the work that he's done in what we call the National HVAC Demand Response Atlas. So without further ado, I'll whip into the presentations. We've probably, got to push for time here because there's a lot of material to cover, as you can see. So why digitalisation? Digitalisation is a term that's very strong in Europe. Perhaps I don't hear it quite so much here in Australia, but this sort of idea that if you can actually create the IT backbone inside a building, you can get smart buildings, and smart buildings can be used in any number of different ways, from security, and access control, through to management of equipment, sustainability reporting, even through to comfort management and occupant engagement in the building. So many different things that you can do if you can actually get access to data and apply modern digital technologies. In the context of the energy efficiency component, I mean, there are many other sort of components as you saw in that previous diagram, but from the energy efficiency component, you know, we're still there with the age-old adage that you can't manage what you don't measure. But of course, that journey between management and measuring is a substantial journey, starting off at data collection, consolidating that data into information, and then once you've consolidated it, the ability to apply artificial intelligence and mathematical modeling to deliver insights that can be brought back to the building for action. And I've put a bunch of the sort of digitalization techniques there that are emerging that we would like to enhance the use of. But we've got a number of barriers there. I think that the state of the industry as we see it at the moment is that we have lots of those building services all coming into the building as silos and leading to duplication in the smart building space, duplication of infrastructure. And so there's great potential for cost savings there. Obviously, there's an age-old issue around proprietary systems and vendor lock-in. An interesting one, and this is one that Subbu will be covering off on, is sort of this poor state of digital documentation. It's all very well to even capture data, but then how do you make sense of the data unless there is a whole lot more information that underpins the data you're collecting? And of course, cybersecurity, privacy and data sharing concerns is another barrier. And the Q&A with Arne Hansen around digital sovereignty certainly goes to talking a little bit about that barrier. So in terms of philosophically, the way we've structured it, we see the data clearinghouse as being a sort of collaboration infrastructure to help the industry scale. And sort of showing this diagram here is sort of like a data exchange. We have many different data sources. Some come direct from the building, some come from the cloud, as I showed in the previous diagram. But then there are multiple usages as well, of which renewable energy enabling is one of the core usages there. And the key, I guess, is that consolidation of all these data sources so that a given user of data can bring together data from these different sources for their application, and we can federate that in one place. The cost reduction potential here is from data reuse, that is, collect the data once, but then use it multiple times. But it's also about when you develop application code, it's the ability to take that code from one building and take it across to other buildings with a minimal amount of bespoke coding. And of course, we're driving for rapid onboarding of buildings in order to help scale these technologies and to drive down the size of the building in which this could be cost effective to implement. So this idea of a many-to-many versus a one-to-one digital approach, I think, is important. And the way we sort of envisage that working out is this idea of the data clearinghouse as a multi-user platform for data consolidation and hosting of services. And it becomes the glue or the binder that sort of connects people who have got data with people who would use data. So data sources include those IoT sensors, the BMS, but also the cloud providers. And then the users of data could be, and the applications that could be used, created, many and varied. Clearly data analytics, fault detection and diagnosis is a classic. And from the point of view of the demand response and the flexible loads, this sort of supervisory controls is one of the components that we want to promote in some of our projects. How will it make a difference? I've sort of got a little diagram there around sort of breaking down the cost structure of delivering these data-driven applications. Part of it is sort of hosting the data in the cloud. Part of it's operating the actual platform for data collection itself. And then there's the component, which is the sort of value-added service. Ultimately, it's that application service component, which is the bit that adds value, and we just don't want the bottom two components being repeated over and over again by different people who would come into the building. We've been doing a bunch of service discussions, surveys with different people, and there may be 6 or 7 or more different services all trying to get access to data in a building. So bringing down the costs, driving adoption of technical standards, and Subbu will be talking a bit about that, building skills and capacity in the industry, and Australia is quite a leader in this space. We have a number of successful examples of companies that have grown up here in Australia and now working internationally and exporting our 21st century jobs, importing or bringing them into Australia. We want to drive open innovation, so the conversation with Iain later on is sort of around that, and a trusted marketplace where we can grow the pie, increase the number of buildings, and bring some independent monitoring and verification to drive EPC and renewable services. So just in terms of the projects that we've got, and I'll use that diagram that I showed before as a way of sort of explaining it. We've got 2 projects up, DCH1 and DCH2, that are really looking at the that core platform there and testing out 2 different software platforms for their applicability to this paradigm. We've got a project with New South Wales Schools, DCH6, which is looking at the combination of photovoltaics, batteries, and load management in schools. With 2,900 schools around New South Wales, if they were all turned air conditioning and air conditioning is being installed across them, if they were to turn on all at once, as they would, that's sort of something like 400 megawatts worth of power generation being used to provide the air conditioning for those schools. So a big portfolio, a big building typology that we need to address. And DCH3 is one that is just in the contracting phase at the moment, and that's looking at management of air conditioners in retirement living applications, particularly testing out a new IoT device, which includes both sensing and control capability, and retirement living is one of those things where you have embedded networks where the ability to manage power consumption has real value. So we are continually looking now for additional projects that could make use of the data clearinghouse capability and demonstrate the enablement of renewables in different building typologies, different climate zones, and how that can support getting a clean, affordable, and reliable electricity system. So I'll stop there. I won't take questions right now, and I'll hand over to Subbu for the next presentation, and then we can take a few questions there. So store up the questions, and of course, please do use that Q&A thing to type in your questions. So over to you, Subbu.
Thanks, Stephen. All right. Thanks, Stephen, for that introduction. Yeah. So the purpose of my talk is actually to provide some sense in terms of how do we make better use of building data, primarily using semantic models. I'm using some terminologies here. I hope I'm able to explain them, as we progress through the talk. In terms of smart buildings, again, we all know the smart buildings industry is growing in the last few years, and with more IoT sensors coming up, people are actually using more sensors in buildings and more data is being generated. But if we look at, are we using all of this data effectively? Perhaps not. Can we use the building data that's actually generated across different systems and applications in a seamless way? That's what I mean by interoperability. For example, even within a same building, can we use the information collected from one set of building operating systems into other set of building operating systems, or among a community of buildings, or even with service providers and also with the energy market? So the answer is perhaps yes, but with lots of difficulty, but with some, most of the data it's perhaps not. So how do we really address this? Before we jump into that, I just wanted to spend a bit of a time looking at what type of building data we have, and what are the limitations with that. Again, for people in the building industry or HVAC industry, this is probably pretty evident. I might still quickly run through them. If you are collecting data from sensors, let's say, I'm having raw data, 86.32, it doesn't mean much, unless I provide, more information around that numeral. For example, if I attach units and then if I attach timestamp, then it becomes easy that, it's actually a percentage value, and it's also a time series data perhaps. And if I provide more information like RH and SA, again, for people in the building industry or HVAC industry, it becomes evident that it's actually measuring relative humidity of supply air. And protocols like BACnet, point labels, go further and they try to provide more information than that. For example, I have circled, 3 sets of information there. One is the first set is actually the location specific information, and the second set is actually the equipment specific information, AHU06, and then the supply air relative humidity. So the main message I'm trying to convey here is, as we provide more and more information around the data, the metadata, the usability of the data actually improves. By the way, all the data I present here in this talk is all collected as a part of DCH1 project from 3 CSRO buildings. So they all are real data that's coming through. Even though we have BACnet point label providing more information around this data, we still have difficulties in terms of using this data across different applications. And also, if someone wants to understand more about the contextual information, for example, 86% humidity perhaps looks high, why could that be? Is that because, maybe something is wrong with the dehumidifier or something is not operating properly? If you need to understand more about the contextual information, this doesn't tell us much. Again, looking again more into what type of data we have, there are 3 types of issues, I would say, with respect to making the data more usable. The first one is, as I said, it's the heterogeneity. We have different, type of systems used in buildings, starting from building management systems to IoT sensors, and even among the building management systems, people tend to, have different contractors who actually label all these points differently. Again, I have shown example from our 3 CSRO pilot sites. If you look at outside air damper, for example, you can see here, the one that's coded in red. In the Newcastle site, that's actually listed as OA space DAMP, and in Black Mountain, it's actually OA underscore DMP, and in Clayton, it's actually OA DMP. So if someone was actually searching for this using a keyword, they wouldn't be able to find this across all the 3 sites. And again, you can see the same thing applies to other examples I have shown here as well. Moreover, as I mentioned, in addition to the metadata, we also need contextual information about the data, which is currently, again, it's probably available, but it's often hard-coded, it's inconsistent, and it's incomplete. Once we have the data, we obviously want to maintain data and understand, how the system is behaving over a period of time. And buildings obviously have a lifespan of, let's say, 50, 60 years and beyond. And how do we make sure the data that we capture and the information that we have can be maintained over a period of time and updated easily? That's another challenge. So how do we improve the usability of this building data? That's where we look at various options, and some of the things I mentioned about, standardizing the naming conventions, introducing things like tags is a way to address that. and also making the data machine readable using consistent methods and ways to avoid manual efforts, and augmenting data with semantic information, contextual information that provides more information about the data is an important piece of it. And we are obviously not talking about small volume of data. We are talking about perhaps a building having a few thousand points. And if you are able to visualize this and understand what's happening with all of the data, a way to visualize this and then update and modify this easily is going to be very useful. I think the holy grail here is, what if we had a unified single source of truth for all the building data sitting at a single place, so that all the building stakeholders can actually access and make use of that? And what's actually preventing us from doing that? And I think that's where the semantic models come into picture. We discussed about data, we discussed about metadata related to data, and by adding context, relationships to the data in terms of semantic models, we are able to make much more sense of the data. So in essence, semantic models actually help the smart buildings much smarter. This is probably a complex slide. I have thought a lot about it along with my colleague Dan Hugo in terms of should we avoid terminologies here or should we keep it simple? But again, I decided to keep them. But let me try to explain it again. How technology. I'm not a semantic modeling expert, but let's say if we think about how do we construct semantic models of a building, we spoke about data, metadata, and also the context related to the data being used. In order to create a semantic model, you use this information, the metadata and the context related to the data, using domain specific. Here, obviously it's a building domain specific ontologies and schema. So the ontology actually helps us define different entities in a building. I'll actually talk about an example very soon. And also a schema helps us actually constrain them in a way that can be implemented, the relationships. So once we have a conceptual schematic model, there are tools that we can use them to formally implement it. For example, I have listed a resource description framework, RDF, as a tool to implement, let's say, semantic models using triples. And there are other tools available as well. And once they are, formalized using standard methods, we can access, again, standard tools that are available to use these models. For example, SPARQL is a powerful querying tool that is actually used to unpick data from these semantic models. So once we have a semantic model available, it will actually be linked with the real data, the database. And by having these two things cross-reference to each other, we will be able to query for data and gather information about the data and the context and what's happening with the data, and also able to use various applications with a single semantic model. We don't have to keep constructing different models, or we don't have to look for data every time we have a different application. Let me, the previous slide was, a bit abstract. I'm trying to explain that through example here. And again, people with the building industry and HVAC industry background, this is a typical air conditioning system, chiller-based air conditioning system. So what I have here is actually a chiller and a AHU that actually delivers cooling. I have kind of consciously avoided using the heating coil here, cooling coil, and then the AHU actually has got ventilation airflow as well as return airflow, a mixed airflow that's supplying to a room, and the room has an occupancy sensor. So let's say if the room temperature is warmer, if we are trying to understand, let's say, costs of the room temperature being warmer, it could be due to the occupancy being higher, it could be due to the outside air temperature being higher, or it could be something to do with the supply air temperature. And again, unpicking what's happening with the supply air temperature, we need to kind of traverse back. We can go, as far as chiller. If the chiller is faulty, if the chiller is not delivering sufficient cooling, that could lead to supply air temperature being, different. And also, if there is anything fault with the AHU flow system, that could lead to higher temperatures as well. So how do we understand this in a semantic way in terms of, understanding these linkages? That's where, this is actually an example semantic model of this previous, schematic. I haven't fully completed it. I have actually used a brick semantic model to borrow some terminologies here. So we basically define 3 classes here. For example, what I have shown on the top, I believe you can see my cursor moving, I define basically a location class, a point, and an equipment. And if I look at chiller, I basically list all the equipment here. And also I'm able to define standard relationships defined in the ontology or schema to link various equipment and also link various components. For example, a chiller would actually feed to an AHU, and an AHU has got pot. So I use a pot relationship, has pot relationship between fan and cooling coil. And AHU will obviously have sensors. And I am using a relationship called has point relationship in order to define different sensors in the AHU. And AHU feeds to a damper, and a damper feeds to the room. And again, temperature sensor, based on the occupancy, it may be, let's say, closing or opening a damper to allow air into the room. We can actually use a controls relationship to actually link them. So by using this ontology and schema, now you can see we are able to describe a mechanical system in terms of its relationships and also the components as well as points, as well as the equipment. We also have the location information available as well. Understanding the the complexities or the limitations with all the building metadata as such, there are various efforts across the world in terms of developing metadata schema or making the building data reusable. I didn't go into the details, but just to give you a snapshot here. Again, people may be familiar with the BIM, used in the construction industry, and currently, by using IFC classes, we are looking at a common data exchange model during the construction phase of the building. And building ontology, topology ontology is another approach that's actually looking at coming up with a standard schema that looks at the topological concepts in a building. Haystack, again, people will be mostly familiar with that. It's a standard naming approach to provide standard naming convention. Again, I have shown an example from one of our CSIRO building points defining a hot water valve. You basically have different haystack tags to define that. And brick, as I mentioned, it's a way to actually add semantic information to a building. It's again mostly used in the building operating phase. So we have actually got the location point and the equipment details. And then by using these relationships, we are able to actually provide the contextual or the semantic information around that. There are efforts, like the ASHRAE BACnet committee that are currently looking into integrating, let's say, coming up with a standard way to describe the semantic information, combining, let's say, haystack and brick. And there are efforts that are ongoing right now in order to make this more standardized. So what are the benefits of these semantic models? I touched upon them, but just to summarize, there are, for example, if you are looking at building specific applications, Stephen actually spoke about various applications a platform like a data clearinghouse can make use of. And the main benefit of a semantic model is the application portability. Once the application is made available and the semantic model is there, without making much changes to the semantic to the applications, we should be able to implement those applications across multiple buildings. And also, I mentioned about powerful querying capability available through the semantic models. Once they are available, let's say, in tools like RDF, by using SPARQL, we should be able to identify complex relationships by using the semantic model. Again, I propose to show a couple of examples here. So what we have here is actually, again, one of the CSIRO sites that's actually providing, cooling to a room through an FCU coil. We also have a few rooms in the building where the FCU, there is no additional FCU, the AHU directly supplies conditioned air into a building. So in this example, what we are trying to do is actually to find rooms that have temperature sensors, room temperature sensors, and also we are trying to find AHUs that are actually supplying cooling to this room. And also we are trying to understand what is the temperature set point of the equipment that's delivering cooling or heating to this room. So by writing this SPARQL query, what I have shown here as a box, we should be able to obtain all of this information. And I have again shown an example. There are lots of more building points. Again, just to give you an idea of what the SPARQL query actually provides us, The first column actually provides a set of building points that have room temperature sensors, and I'm able to also obtain all the AHUs associated with that. And if you look at the third set, I'm able to list all the equipment that are actually having a temperature set point related to that room. So if I look at the first three rows, for example, I'm having AHU 03, 09, and 19. Whereas when I look at the fourth row, this system actually has got a FCU. So the query is actually able to identify the set point actually comes from a FCU, not from the AHU directly. So I'm able to actually traverse backwards and then identify which system or equipment is actually feeding to this room, whether it is FCU or AHU, without specifically asking for them. That's the benefit of traversable query like this, and SPARQL can actually handle these kind of complex queries easily. Just to show another example, we spoke about application portability. Let's say if I am looking for finding supply air temperature and outside air temperature between two sites, again, CSIRO Black Mountain site and Newcastle site, by writing this SPARQL query, I'm able to actually again obtain these points list straight away. And I have shown a plot here, outdoor air temperature as well as supply air temperature, for a few days last week. I think, yeah, so I think that's the benefit of the semantic models. Thank you.
Thanks very much, Subbu. We're probably running just a smidgen behind time, so I have got time for a little bit of a couple of questions. And the questions could be either on the higher level philosophical stuff that I presented, or the more detailed work there around the semantic modelling. There's a question that's come in on the Q&A function, and this one to you, Subbu. There are already globally accepted industry standard naming and tagging like Project Haystack. So is iHub planning to build their own system or work to support and enhance existing systems?
Yeah, I think we are looking at both. As I mentioned in my presentation, obviously Haystack, Brick, there are various initiatives in terms of developing standard, schema and tagging system for buildings. So our intention would be to make use of what's existing already and then identify gaps and then develop tools to bridge those gaps.
And I'll just add to that we're part of this International Energy Agency Annex 81 on data-driven smart buildings, and there's work on that there. So whatever we're doing here would not be done in isolation. It would be with the community who are actually developing this stuff. Because yes, there's no point in Australia going off and doing its own thing here. We would be part of international efforts, and that's why it's important to be part of those international standards committees and things like that. So good question. Any other questions? All right. Well, if there's no further questions there, then perhaps if I could call on Arne Hansen, and perhaps we can have a bit of a discussion around the issue of data sovereignty. The idea that companies will want to maintain control of their data, and to what extent that sort of influences the design of the data clearinghouse, and to what extent does that create either a barrier or an enabler here. So please put your put in your Q&A questions there for Arne, but before we get to those questions, I will just give Arne an opportunity and perhaps have a couple of questions to kick start. And so, Arne, can you just tell us a little bit about yourself and Buildings Evolved, and sort of how you fit in this this puzzle?
Sure, great. Good afternoon, everyone. My name is Arne Hansen. I'm the principal at Buildings Evolve. We're a small technology consultancy business. My background is in working for building services companies, worked in electrical and mechanical systems integrators. I've worked in software development houses, and the particular interest for me has been, and over a very long period of time, has been the digitalisation, although it didn't necessarily have that phrase or that terminology back in the day, but digitalisation of systems. And more particularly these days, working with large corporates and government to integrate different data sets together. So typically where they've been dealing with multiple vendors and multiple vertically integrated solutions, we are sort of raising that is really to try and merge all those different things together so that the client can achieve the outcome that they're looking for.
Cool. So, as you talk with your clients there in the buildings industry, how are you seeing them respond, and what are they asking from you around this idea of data sovereignty?
Well, just to clarify in terms of data sovereignty, I think I just want to say data sovereignty typically means around moving data into a particular country to sort of save its citizens from imprimatur from external countries and their laws. So a classic example would be Canada wanting to hold its citizens' data in Canada rather than in the US because of the Patriot Act, for example. But I think just more broadly what we're talking about really is around the data sovereignty for each individual organisation and what they're looking to achieve in terms of control and ownership of their data sets. So on that topic, the typical thing that we will be brought in to do is to look at the outcomes that the organisation is trying to achieve, usually around reporting and compliance obligations that the organisation has, be they voluntary or mandatory requirements. So, for example, a company may be looking to join the Carbon Disclosure Project, they may be looking to do the NYSE Feel Good Index or all sorts of different manner of additional reporting over and above their mandatory requirements in order to attract funding from ethical investors. So this is sort of the ESG play which you may see in the media around sort of socially responsible or ethically responsible companies. So this is one of the mechanisms that they use in order to be able to make that possible. Because they need a large array of data being used for multiple different reporting outcomes, and they need a single source of truth in order to achieve that. And they may also be purchasing, and typically this is not an uncommon thing, be purchasing carbon credits or carbon offsets using the data that we're collecting. So it then has direct financial implications for that organisation, and that they then therefore need to hold the carbon accounting to a very high degree, a very high standard. So that's
some of those data things are sort of long time horizon data that sort of monthly or annually, and the data clearinghouse is clearly targeting the shorter time frame data collection. Are you seeing companies with an interest in that shorter time horizon data, and how are they using it?
Yeah, I mean, these guys have typically started out with the more less granular data sets that they could get their hands on, and then it's slowly starting to narrow in on BMSs. So you see they usually start with collecting invoice data and things like that, and then they start to hone in and more in on high resolution building data. So that's less around obviously the reporting obligations, more around building optimization services, and obviously those organisations are keen to continually improve their building stock in terms of the efficiency of that building stock, and so it sort of ties in really more broadly with the ESG perspective about having specific KPIs on what they're trying to achieve, and then being able to demonstrate those KPIs are being met. So
what are the sensitivities? What are the sensitivities around this kind of data?
In terms of?
Well, sensitivities could include privacy issues, business, commercial risk, or anything like that.
Yeah, there usually is a pretty high degree of governance that sits over the top of any of these data sets. And these organisations, usually when they go through a transformation, a digital transformation effectively, they also, the power structures and so on in terms of who has access to data, who can control the data, also becomes quite paramount and quite important. Obviously there's privacy concerns in that, but there's also just who needs to have access to what, those sort of conversations. So usually a large component of the consulting work that we will do will be to go in and work out a role-based permission structure for access to data and who can see or access what data. So it's a very important part. So we just call it data governance typically, the data governance procedures, and we advise our clients on those elements.
And from a technical perspective, are these things being built in a bespoke kind of a way, or are you seeing platforms out there that are servicing this sort of well? And you know, to what extent can the sort of the technology help to manage or support the governance?
Well, one of the sort of big I suppose stumbling blocks for any one particular vendor when they're dealing with a property portfolio is risk mitigation from the organisation's perspective. So typically, large organisations will not want to put all of their eggs into one basket, and they particularly won't want to do it with small to medium-sized enterprises because they view that as a massive risk. So I mean, I've dealt with property portfolios in the past, for example, that have said, well, we've got roughly half of our buildings with this one particular vendor, but we're not going to give any more to them because we can't let that sort of penetration by that single vendor become more than that, because then they'll have us over a barrel effectively, is their rationale. They're looking at it from many angles. They're looking at it from the risk perspective. They're looking at it from how do we gain value out of the data? How do we have a single source of truth? So for them, having vertically integrated silos and vendor silos is anathema to that outcome that they're trying to achieve. And the same is true. So this is usually property trusts, large property trusts. We're talking large size property trusts and government property trusts are usually the ones that lead these technological innovations in my experience. So, but we will see that come through into the SME space. But I guess going back to your point, are they building these things bespoke? The answer is yes, they are. So if they're a big organisation, they've got a budget, and they've got an IT department. The IT departments are typically onboarding this stuff into their sort of core functionality and are building out these databases in order to extract control data. So one thing, for example, is I know one property trust that we've worked with in the past has changed the paradigm from them requesting data from their subcontractors or their vendors, and instead shifting it around so that their subcontractors are asking them for data. So that's I suppose, when you look at that, that's really, I suppose, in some ways what the data clearinghouse is about. Is really trying to sort of, he's really trying to provide that capability through to the SMEs and other parts of the market. So instead of it just being limited, really, that sort of capability and functionality being limited to a very small set of leading companies, blue chip companies, and some government departments, we need to really be able to extend that out to the broader economy and various different sectors of the economy. So I liken this to sort of like the railways, you know, back in the 18th century, so 19th century, where you had multiple railway companies in England building the same line in parallel to each other. You might have 4 lines, 4 different companies building the same line from one city to another, and at enormous expense and enormous waste of resources. So I sort of see the data clearinghouse a little bit in a way removing sort of that duplication of effort that's being undertaken over and over and over in the marketplace.
Thanks, Arne. And Jack Russell says, what about data ownership at local building portfolio level and the vendors involved? So I guess looking for some comments on the vendors. The suggestion is that most analytics and BMS companies are reluctant to openly share data.
They are. Ring true? It does ring true, but we also see a lot of pushback from the clients against that sort of notion, and I think unless the client, if the client doesn't know what they're looking for or have specific requirements, then they will be sort of generally shepherded down those paths. But I think certainly the clients that we're dealing with don't want to have a bar of that type of attitude, and they're coming at it from, well, why is this special? Why is this data special? You know, and they honestly can't understand why it needs to be so sort of locked up in the way that it is. And that's just their perspective. Now, obviously, there are reasons why the industry has done it the way it has over the years, and certainly in terms of support agreements and so on, there are good reasons as to why things have happened the way they have. But I think that you know, sort of reading the tea leaves here, it seems like there's a bit of a move afoot towards democratization and open sourcing of solutions to be able to bring in the operational technology into the information technology fold, and that's really what these organisations are seeking to do. And that really is also part and parcel of what the data clearinghouse is about.
Got a question here from Brendan. Is the intention to measure local site energy production and storage feedback to the grid also, and compare that against use demand to gain efficiencies? So what sort of efficiencies do you expect to be able to be achieved here through more fine-grained data measurement?
Well, in relation to, we're sort of involved with the DCH6 project. We've been working with the New South Wales Schools Department for over 5 years now in various different capacities. And we've done some economic modelling on this. For the schools, it's a multifaceted win for them in a way. So with for those unfamiliar with New South Wales politics, there was before the previous election, there was a $500 million commitment by the current government to put air conditioning inside classrooms across the state. So this obviously, you know, was a bit of a challenge technically because the schools were never designed electrically to have those kind of loads in them. So what we found was that it necessitated electrical upgrades and sometimes transformer upgrades, sub-mains upgrades, switchboard upgrades, and so on and so forth. So what the study and some of the work that we've done proved was that we could, using a control system and even a basic control system connected to the supply authority meter with a high frequency data feed, we could manage the demand generation and storage in tandem to ensure that we're not going over a particular limit in terms of demand. And that differs, I suppose, from just looking at it purely from a solar and battery perspective. Trying to fill demand with more generation and more storage, instead taking the other approach and saying, well, you know, what can we do about demand management, demand control, in addition to the solar and batteries? So really trying to take that mix of technologies, the energy mix, and trying to control that in a much more coordinated way. Does that help answer the question? I'm not sure if that fully answers it.
Yeah, that's good. Kind of coming to a close there, so if there are any last questions, please get them in. But I'm just wondering about the sort of skills gaps in this industry, and you know, where's the buildings industry at in terms of managing its data, and do we have a problem in the industry or with skills?
I have seen some incredibly amazing things happening in this industry at the moment in my interactions with integrators across the country, and going to various different integrator conferences around the world. You can see that the industry has taken note of the challenge that is being presented to it, and there are certain players in the industry that are moving very, very quickly to address those skill shortages. And I would say some of the integrators that I've spoken to are world leading really in terms of their approaches and their principles and what they're doing. So I think there's a very good news story there, and I think we're well positioned to really accelerate the digital transformation of this industry going forward.
Cool. All right, I think, oh, here we are. Here's a question from Ray Much. If I have my own established data lake, what does iHub do for me? I own the data and my preferred vendors have access to it already, so I can't see any benefit. Is this product more designed for customers who don't have that level of sophistication? If so, how does this type of customer get the data into the iHub cloud if I don't really understand how to do that? This is a really good question, and we have those different layers, I guess, of sophistication on the sort of the building owner side of things, and some may well already have that. And then we have new players who bring capability sets, particularly in sort of artificial intelligence and machine learning and stuff, that you know, their core skill is in that area, not necessarily in the data collection bit, and so the ability to sort of get open innovation is indeed one of the sort of core questions. And that's probably a good segue then to pass over to Iain Stewart. Iain Stewart from Exogenics there. Hi, Iain. So, yeah, that question may sort of be in some ways targeted at you as a kind of a new entrant. Can you tell us a bit about what you do and how you see your company growing in this kind of space?
Yeah, sure. Hi, everyone. So I'm Iain Stewart, the founder of Exogenics, and we're a chilled plant optimization software provider. So what we do at the moment is to collect data from the existing BMS, and then we use that data to build a digital twin of chilled plants, everything in the central plant, so chillers, pumps, and cooling towers. Then we'll run an optimization loop to determine for all given conditions what are the optimal control settings for those pieces of equipment. And the objective of that model is to increase plant COP, so keep COP at a maximum. And then using the results of that model, we'll collate that and turn it into a control strategy, which is loaded onto a building controller and installed on site. So I suppose at the moment, one of our barriers, and I think one of the ways that the data clearinghouse can help, is that we do have to have that physical aspect. So to actually go into the building and get that data from the existing BMS, and then the second point of access is actually installing the controller on site and taking over control of the central plant. But yeah, I sort of see the data clearinghouse as a nice way around both of those, both on the data collection side and in the control side going forward.
So what does big data mean to you, Iain?
I suppose it depends on the context. Big data for us, I mean, it's kind of a funny one, big data in the building space, because most of the buildings I go into typically have trend logs for about 6 months. So my data collection window spans about half the year, and then we can't really train our models. So I suppose buildings at the moment is not as big as I'd hope it would be. But big data for us is really having enough data there to be able to train our models, as they can only really learn from what they've seen using the algorithms that we use. There's got to be enough in there. So I suppose ideal big data in a building sense for us would be having potentially years worth of data that we can go to train our digital twins, and also baseline existing energy usage so that we can measure and verify the savings that our software is producing.
Cool. And so what do you see as sort of the barriers in the industry that you face as a kind of a new entrant?
There's certainly no shortage of barriers. I think first and foremost, as was touched on previously, that the reluctance to share data, I think, can be quite a significant barrier in the data collection side, and then sort of related to that as well, that the reluctance to give up any sort of control. So the incumbents, you know, it's obviously they're going to be consulted when any change to the building is happening and the building controls, and there's a fair bit of reluctance there to have a new piece of kit come into the building. So that's a fairly major barrier that we're coming up against at the moment.
Cool. And so, so what way do you see the, in terms of the implementation side of things? We've had some initial conversations there. How would you see yourself potentially interacting with the data clearinghouse?
I mean, the ideal solution for us is to integrate in the cloud with the data clearinghouse and then essentially be an app on the platform. Yeah, as was touched on by Subbu earlier, I think with the brick schema or the like being used, where we can just have one set of code that's applicable to essentially any building type, then it almost becomes a matter of just flicking a switch and saying, yes, we'd like this service, this software to be enabled for any building that's been onboarded onto the clearinghouse. I suppose there's quite a few steps in between from where we are now to that. And I think getting a few buildings onboarded onto the clearinghouse in the first instance, even for a data collection, so there's good visibility of the data there, and it's able to be collected for more than is industry standard at the moment, and possibly in shorter time steps as well, just so we can train our models better and get more accurate in terms of our controls. But then in the long term, I think once the measurement verification aspect is another great one with the data clearinghouse, and potentially that final step is then implementing the controls from the cloud, having that two-way integration there.
Cool. So where do you see your company going in future?
Well, I suppose where we're at the moment is purely an energy efficiency type solution. So we're backwards looking. We see what are the operations and where can this be improved. But in terms of where we'd like to go, I think HVAC plays a really important part in grid stability, and that's only going to become more important as well. So I sort of see us transitioning once we've got boxes in buildings, transitioning and becoming more of a grid stability facilitator almost, maximising the use of on-site renewables, and then even if you've got customers that are exposed to the wholesale price, trying to suck up as much of that negative priced energy as possible when there's too much solar on the grid. And then reduce usage at other times. And I mean, a supermarket's a perfect example of that. When you've got a walk-in freezer, you essentially got a big battery there. So yeah, being able to use that excess solar and then turn off in times when we're using more fossil fuel.
Cool. Thanks, Ian. So if there are any questions, keep the questions throwing in the Q&A section. So if there's questions, I'll come back to you, Ian, but there's a question here from Sally King-Carmichael, which is a good one that probably Subbu, are you there, Subbu? This probably could have come up before. I'll direct this one to you, which is, how do you anticipate the data acquisition process playing out, particularly in terms of who will pay for the work? That's the integrating, tagging and modeling there.
Yeah, I think that's certainly an important question. We actually tend to call this as an onboarding process. So we are, at least, again, in the context of data clearinghouse, we are actually trying to address this by developing, let's say, a module that will actually address this challenge in terms of bringing in data from heterogeneous sources, various building platforms, as well as IoT sensors. While doing that, we are also trying to make sure we gather, sufficient semantic information related to the building points, and then as a result, able to create a, support creation of a semantic building model as well. And I acknowledge, that's not an easy effort because, even with our, going through this exercise with the 3 CSIRO buildings, we have seen the data is scattered everywhere. We have drawings sitting somewhere in somebody's shelf, and then some of the drawings are not digitized, and then we have building management system manuals and things sitting in different places. So this has to be formalized, but by going through a setting up a onboarding process, we believe we will be able to standardize this to a large extent. And also the key thing we need to remember here is, by going through this onboarding process, once we create a semantic building model, we will be able to most likely use it going forward. So it's like, once you do it, you don't have to repeat it. Whereas if you are going through an exercise of, let's say, connecting a BMS system or a set of IoT sensors, you may have to repeat that going forward. Whereas this exercise, the onboarding process, once we are done, I think we will be able to use it. I think that's the main benefit of going through this formal onboarding process.
Thanks, Subbu. And it is a question that we think long and hard about, and are talking to a lot of people about. And certainly, it's in some ways perhaps it's counter to some of sort of industry practice. The classic sort of design and construct approach is keep the cost to an absolute minimum at the beginning, because the developer is well and truly out of the process at the end. And so therefore doesn't have to pay the cost over and over again of having to redo the job and stuff. And so there's an element of there of invest up front to get your cleaned up data so that everyone can benefit from it later on. How you stitch that into a business model that works, that's something that we're working very hard on, and we'll do so over the course of this project. So that's a great question. All right, I think that that's all from the Q&A section that I can see there. So, I think it's important to finish off there with a bit of the sort of the size of the prize bit here, and obviously taking it from the renewable energy enabling perspective. And so I'll hand over to Mark Goldsworth, who's been doing the analysis to work out how much flexible load there is in the HVAC industry. So I'll hand over to you, Mark.
Cool. So good afternoon, everyone. So I'm talking today about the National HVAC Demand Response Atlas project, which is part of the DCH project. So in this presentation, I'm going to cover the motivation for the work, so what we're trying to achieve. Touch briefly on the technical approach and one of the validation tests that was performed. And then, of course, I'll present the results and the key findings. And finally, I'll finish off by find more information and access a visualization tool that you explore. So the motivation. So in New South Wales in 2019, there was 3,500 megawatts of electricity generation capacity that was used for just 5% of the year. So to put that in context, that's more than the output of the largest coal power station in Australia. So this figure here shows total electricity demand in 4 states as a function of the maximum daily temperature. And the size of the bubbles indicates how frequently the conditions occur. So you can see that electricity use is strongly correlated with temperature, and for most states, peak demand on the network is associated with very hot days, and that equates to large air conditioning demand. So where does demand response fit in? Well, as we've heard, buildings have thermal inertia. They can effectively act like batteries, and they can be used to shift demand to reduce those peaks. And the most appealing aspect of building demand response is that the infrastructure is already largely built. It just needs to be controlled. So why are we looking at HVAC demand response? Well, it's helpful to consider an analogy with peak hour traffic congestion. So there are several different approaches that you could take to tackle the problem of congestion. For example, you could increase the number of lanes on the road, which is equivalent to increasing the base network capacity. You could purchase lots of buses, which is like increasing on-demand capacity, and that's similar to using batteries. Or another option is to stagger work times. So in other words, you could spread the demand out and so reduce the peak. And there are different costs and benefits associated with those approaches, just as in the case of electricity demand. So the aim of this work wasn't to compare the different options, it was just to better understand the demand response option. And specifically, the questions we're looking to address were how much HVAC demand response could be enabled across Australia, and when is it available in comparison to when the peak demand occurs on the electricity network. So the approach we took is a top-down disaggregation from electricity zone substation data. So we took 10 years of half-hourly electricity demand data from about 2,000 substations across the NEM and the Southwest Interconnector in WA, and linked that with weather data from the BOM, the Bureau of Meteorology, and building data from the Nexus database. And the steps are summarised in this diagram. So firstly, we used a regression model to separate out the base load and the temperature-dependent load. And then we split the temperature-dependent load into heating and cooling components and applied a statistical model to separate out the residential and the cooling components of the cooling load. So residential and commercial components of the load. And then we applied some demand response models based on building simulations. And of course, I'm not going to go into all the details here, but if you'd like to know more, there's a journal paper that I'll link to at the end that describes the method in detail. So before I look at results, I'll just briefly mention one of the validation tests that was performed. So how do we know that the model is working? So we had data from approximately 70 houses where the air conditioning circuit was separately metered along with the total demand, and we used the model to estimate the air conditioning demand from just the total demand. And then we could compare the model estimated air conditioning demand with the actual metered air conditioning demand. And the results are shown in the four figures here. So essentially, the model performs well, and it was able to estimate the total air conditioning demand as a function of time just from the total demand. So we did do another few validation tests, but I won't cover those now. So the results. So this is the main results. The figure shows a series of box plots of the demand on the NEM, the National Electricity Market, as a function of the hour of the day. And the black line here, this is the 99.5th percentile demand, which we've used to indicate peak demand. And the blue dashed line, this one here, shows what the 99.5th percentile demand would be reduced to if we could implement demand response across commercial and residential buildings. And that reduction is about 1.2 gigawatts from the peak. And you can see the time of the peak is also delayed by about 2 hours. So in terms of the timing of when the demand response is available in comparison to when peak demand occurs on a given network, so this figure shows results for the two networks I've chosen. So Actu AGL, which is Canberra, and Ergon, which is most of Queensland outside the southeast. So Ergon has a high PV penetration, and the peak demand occurs between about 3 and 8 p.m. And it tends to be slightly later than when most of the demand response is available. In the case of Actu, the peak demand occurs earlier, and there's a better alignment with the available demand response. And the results for other networks in New South Wales and Victoria tend to be more similar to Actu. And it's interesting, daylight saving is possibly also a factor here because it effectively shifts the air conditioning load to earlier in the day. Some more results. So looking at results per zone substation. So this figure shows the percentage peak demand reduction from commercial building demand response to the Energix network. So it's the percentage drop in the peak demand that you could achieve by implementing demand response in commercial buildings. And the red dots on the map indicate where the commercial buildings are located. And so, as you might expect, the largest percentage reductions in peak demand are around the CBD, but there's also significant reductions right across the network. For other DNSPs, for other networks, the median reduction in peak demand from commercial building demand response is between about 1% and 4%, and from residential buildings between about 5 and 15%. So another results slide. This one's interesting. So this table summarizes the change in the timing of the afternoon peak demand for the different networks. So it shows that for many networks, the peak is occurring at a later and later time each day. So I should say this is based on data from the 10 years to 2017. And the amount that peak is being delayed seems to be correlated with the amount of distributed generation. And in the longer term, this is likely to preference commercial demand response over residential demand response over commercial demand response. So last slide now. So how can you access, there's a lot of data that's being created by this analysis. How can you access it and look at the results for yourself? There's an online interactive visualization tool that we've developed. The link is there. So with this tool, you can look at the overall demand as well as the estimates of the commercial and residential demand response for a given network or for a given individual substation within a network. And you can look at the results for different months, for different times of day or maximum temperatures of the day. So there's also a summary report and the journal paper there that gives a lot more background and the technical details. Thanks very much.
Cool, thanks very much, Mark. If there's any questions about anything that's been said on Mark's presentation or to any of the panelists, then happy to take those. I see that there was one that I missed, which came from over the chat function from Erica. The question is, what happens to the data if a building is sold? And certainly the idea of the data clearinghouse and there is to ensure that data is consolidated such that it is sort of owned by the building owner and can be transferred across. And I'm sure there are other tools there, but certainly that idea of consolidating data is so that it can transfer with the building is important.
And just on that topic, we've had owners of buildings that have ripped out BMSs as they take ownership of a new site. Again, more duplication and waste. So the data clearinghouse should, in theory, be able to allow you to go transfer ownership of building to another owner, and then you're done. It should, in theory, make the whole process much more seamless. Sorry, just chime in there, Stephen.
Yeah, no, that's good. Marie, are you seeing any questions that that I'm not seeing?
No, Stephen, nothing else has come through at this stage. We might just give it just another minute or so before we wrap things up there.
Yeah, cool. So I certainly want to encourage anyone that's online. If you have any projects, we are open to for business, so to speak, to consider new projects. There is a process that we go through. Starting off with an expression of interest to check the alignment with the objectives of iHub. And out of that, if there seems to be good alignment, we go through a project proposal, and that goes to the industry steering committee, which is made up of representatives of each of the aspects of our industry covered by iHub. And really, we do want to make sure that we're engaging with industry to the maximum to support companies to scale their products and to achieve impact in terms of both enhancement of renewables, but also growth of Australian industry. Got a couple here. Jack Russell says HVAC BMS systems always seem to lead the way with big data, but what about other building services, electrical, lifts, etc.? In the context of building services, and that's a really important point, actually. And I probably should have said that before. From my perspective, digitalisation, if it all relies on energy efficiency savings to pay for it all, then I think we will struggle to see scalability and widespread adoption. And it's as you bundle up the value streams from, as you say, Jack, these other elements, that you actually end up with a compelling case. So I think that's really important. And a point to note, and that's certainly the perspective that we're taking. Don't know if any of the other panelists have got any thoughts on that point about other building services and not just the BMS system.
I mean, I think everyone's sort of in the same boat, really, in terms of where they're at. I think the bigger challenge, though, is how, using the data clearinghouse, can we integrate, BMS as one component, but, can we integrate those lifts? Can we integrate other building systems together using the common architecture of the data clearinghouse to achieve it? I think that's probably the question. And then what efficiencies can we derive from that integration between those different subsystems?
That sort of idea of rail gauging, I think, is important. You mentioned that, didn't you, Arne, before? If every one of these services is putting in their own system in parallel, then our buildings are missing the boat.
I mean, I've seen many occasions where the lift guy will be running his own network, and then the electrical guy will run his own network, and the mechanical guy runs his own network. I mean, literally rail gauge issues. Yeah.
Is there much engagement from vendors in these other areas? I guess we've got a relatively narrow focus in terms of the iHub and the projects that we can fund. That's significantly constrained by the legislation that ARENA operates on, so it must be about enabling renewables. We have a good interaction with different companies in that sort of space. We haven't yet sort of gone to others, out to the full wide audience of potentially interested partners. We'll progressively build up our interactions on that.
Thanks for that, Stephen. So it doesn't seem to have any other further questions at this stage. So I think we might just start to wrap things up there.
Yeah, cool. All right. Well, I'd like to thank all our speakers and panel members. So Subbu Sethuvenkatraman, and Arne Hansen, Iain Stewart, and Mark Goldsworth. Thanks very much for your valuable contributions. Thanks to everyone in the audience for the questions and the discussion. That was a really good session. So hand back to you, Marie.
Yeah, great. So thank you for that, Stephen. So thank you everybody for registering and also attending today's webinar. A special thanks goes to Stephen, the team, and all presenters. As previously mentioned, this webinar is the second iHub webinar for the webinar series. And we would love to see you guys all again at the third webinar, which is the Living Labs on July 8th. So for any more information regarding iHub and to also register for the webinar, please visit ihub.org.au. So yeah, so thank you everybody. The recording of this webinar will become available over the next week or so, and we will send an email out to all attendees letting you know when that does become available. So thank you everybody. Enjoy the rest of your afternoon.